In figure 8.11, pipes 1 and 2 are of diameter 3 centimeters. D3 has 4 centimeter. Alcohol with center gravity of 0.80 enters section 1 at 6 meter per second, while water enters section 2 at 10 meters per second. Assuming ideal mixing of incompressible fluids, compute the exit velocity and density of the mixture at section 3. The temperature is at 20 centigrade. Now gather the data of the given problem, which pipe 1 has a diameter of 3 centimeters with an SG of 0.8 with a velocity of 6 meters per second. And it was stated that pipe 1 is an alcohol. In pipe 2, which is stated that it is a water with a diameter of 3 centimeters and SG is equals to 1. Velocity is 10 meters per second. In pipe 3, has a diameter of 4 centimeters, but the velocity is unknown and the density is unknown, which is what are the values that we are looking for both velocity and density. Now, since it was stated that there's discharge flowing from Q1 and Q2 entering a tank, therefore Q1 plus Q2, then it will exit in pipe 3 is equals to Q3, therefore creating an equation 1. Therefore, another value, another equation that we can form is that since Q, discharge flow rate enters and exit from one pipe, we can state that mass flow rate 1 plus mass flow rate 2 is equals to mass flow rate 3. Since the mass in from both pipe is equals to mass out from one pipe. Therefore, we have a formula for Q, which is AV, then M, mass flow rate, is equals to AVP, or is equals to QP. Now, therefore, we need to solve for Q1. Now, Q1 is equals to AV, the area, which is pi over 4, with a 3 centimeters converted into meter. 1 meter is equals to 100 centimeters squared. Multiply it by 6 meter per second, which lead to 4.2412 approximately with raised to negative 3 cubic meter per second. Now solving for Q2, discharge A2 V2, which has a cross section of same diameter times 1 meter over 100 centimeter squared multiplied by 10 meter per second, which will lead to 7.0686 times 10 raised to negative 3 cubic meter per second. Now, to solve for Q3, since we had stated that using equation 1, we can solve for Q3. Therefore, Q1, which is 4.2412 times 10 is a negative 3 cubic meter per second plus 7.0686 times 10 is a negative 3 cubic meter per second, which would lead to 0.0113098 cubic meter per second. Therefore, Q3 is equals to A3V3. Therefore, solving for V3 is equals to Q3 over A3, since we divide A3 both sides and A3 cancels, therefore leaving us with 0.01130098 over pi over 4. Cross-sectional of pipe 3 is equals to 4 centimeter. Convert it into meters, and Q3 meter cubic per second, which lead to 9 meter per second velocity, which is the answer for the volume velocity for pipe 3. Therefore, we need to solve for density 3. Now, density 3, we can solve it for mass 1 plus mass 2 is equals to mass 3, mass flow rate. Since we stated that mass 1 is equals to AVP, QAVP, yeah, AVP plus AVP is equals to AVP for 1, for 2, then for 3. Since AV is equals to Q, QP1 plus QP2, QP3. Since we don't have a QP3 or Q3, we have Q3 but we don't have density 3, so therefore we could leave it this section to mass flow rate instead. Now solving it, Q1 4.2412 times 10 3 Since alcohol from pipe 1 has a center of gravity of 0.80, we could multiply it by density 1, which is the density of the water. Then use Q2, 7.068, 6 times 10 negative 3 cubic meter per second, and has a same density and has a center of gravity of 1, since it is water, equal mass flow rate. Then it would lead to having a mass flow rate of 10.46156 kilogram per meter cube. Then, since mass flow rate 3 is equals to AVP or QP3, therefore, solving for density has a 10.46156 kilogram per meter cube over the discharge of 3, which is 0.0113098 meter cube per second. Seconds, seconds. Kilogram per seconds, which has the answer of 924.99 kilogram per meter cube. Therefore, we have a final answer of for the density 3.